Technology for Mathematical Argumentation, or TMA, collaborated with leading mathematics educators studying early algebraic reasoning in order to design and implement a computational toolset with which students can construct and share mathematical proofs in the service of learning to be competent algebraic reasoners. Our goal was to have students create a generalized representation-based proof using array tools in conjunction with animation features. The tools were developed and tested within an existing computational infrastructure, Classroom Learning Partner, or CLP, that supports the sharing of student work as a basis for class discussion. We worked with elementary school students with a specially designed 5-day curriculum sequence. On days 1 to 3, the students were introduced to the general array tool for multiplication and animation features, and later to equivalence problems with different size arrays on each side of the problem. On day 4, the students worked on these problems in order to scaffold their thinking toward making the generalization about multiplication on day 5. Students solve these problems in a variety of ways. Create an animation that shows 5 times 4 equals 5 times 2 times 2. Create an animation that shows 7 times 4 equals 7 times 2 times 2. Create an animation that shows 9 times 4 equals 9 times 2 times 2. The generalization challenge required students to move from animations that use specific numbers to animations that were intended to be true for all numbers. We introduced the N notation and fuzzy array tool, which allows students to change an array with 2 specific dimensions to one with 1 variable or indeterminate dimension. Again, there were a variety of approaches that students took in creating an animation that showed n times 4 equals n times 2 times 2. Several students went beyond this as well. We hope to have time to generalize the pattern beyond the relationship between 4 and 2 times 2 to examples such as n times 6 equals n times 3 times 2. So we had this problem available for students who finished the previous one. You can learn about some students' misinterpretations of the fuzzy array representation and our ideas for future design modifications to the tool, detailed in Year 3 of the Classroom Trials section of our website. In spite of some confusion, most students were able to create an animation that illustrated the generalization using fuzzy arrays, as well as articulate why the pattern n times 4 equals n times 2 times 2 would work for any number. TMA is a collaboration between MIT's Center for Educational Computing Initiatives, now part of MIT's Office of Digital Learning, and TERC. This material is based upon work supported by the National Science Foundation.